on Tuesday. So this one is about the mobile harbor project of KAIST 10 years ago. And A1 is there has been two different type of mobile harbor design. And this one is A1 type, which has a size of 250 TEU. TEU is about a unit for counting container box. The full name was 20-foot equivalent unit. There is another kind, standard size, it was 40-foot. So that is doubling the size of a 20-foot TEU. Okay. So this ship, the left-hand side is the ship, or right-hand side is the mobile harbor. It also looks like a ship, but with a large container crane. So the mobile harbor, the right-hand side, has the capacity of 250 TEU containers. Right, and next slide. This looks like a container of 40-foot container. So you imagine that TEU is half of this length, but the other side is the same, so that they can be loaded in mixture of 20-foot and 40-foot can be loaded and unloaded into or out of the ship. And you see that there is a container crane is lowering down or loading up. And then there is a container trailer can handle or move the 40-foot containers at the site. And behind the truck, there are container yards. So many containers are stacked down. It is an open storage yards of containers where we can collect containers and also distribute toward the land side, background land side. All right, and this one is an aircraft carrier of Navy. It is a floating airbase, right? And sea-going airbase. And largest type of aircraft carrier of United States was a Nimitz class. You see the length is 333 meter. And ton, displacement ton, total weight is 100,000. Speed is 30 knots. And the engine is nuclear power plant, and horsepower is big. Okay. Can you remember the largest diesel engine size I mentioned in the class? Anybody can answer? Largest diesel engine size, horsepower, in horsepower.
100,000?
Probably less than
50,000.
50,000. Yes, around 50,000 or more, a little bit more. But that is the range of largest diesel engine. So this one is say that 5 times bigger than largest diesel engine. So you may think about why they choose to use a nuclear power. Okay, and then on this ship, there is a 90 aircraft is carried. You see from the picture that there is only, how many is 20 or 30 airplanes are showing on the deck, upper deck. So the others, around more than 50 aircraft should be stored under the main deck, right? So there should be a elevator for lifting aircraft inside the ship. Power range, horsepower, and watt is related in this way. Number 746 watt is 1 horsepower, and kilowatts is for electric heater in home. You see, we mentioned in discussed or the same picture, and it shows that this is use 2.2 kilowatt. And wind power system, largest in the previous slide was 10 megawatt, right? And also the nuclear power plant, large one is usually 1 gigawatt. That means 1,000 megawatt. So if you want to replace one single large nuclear power plant, you need to install 100 or 10 megawatt wind power system. And if you think about the size of wind power system of around 200 meter diameter, and 100 of that units can be a big area coverage. All right, and this is about underwater accommodation, where you can stay there for longer time. It's a housing underwater. And NOAA is Oceanographic Research Institute of the United States. So they use this kind of house of deep underwater to be a laboratory. And right bottom side, there is a small, looks like unmanned car, which is used for collecting some laboratory materials from the deep sea. Right. And then diving equipment, you may heard about scuba diving. And scuba is a short name for self-contained underwater breathing apparatus. It looks like in this picture. Has been around since 1500, so it has a long history. More than 500 years of use. And in 1943, Gustav Cannan has invented, aqualung was invented, which is pictured like this one, is consists of compressed air cylinder, the yellow cylinders, and the regulator for because the air is compressed, you need to have a lower down the pressure to breathe by human. So regulator controls the air pressure. This is a typical ones. And then soil phase supplied diving equipment. One kind of is diving bell. For Korean students, you may heard about this one many times when there was accident of Sewol ferry. But diving bell has a different types around along the history. So left-hand side, this is an old-fashioned diving bell. There is no compression or pump, only the bell itself. So this bell contains air naturally, and then there is a lowering down the bell. So the human is inside the bell where the air is captured by nature. Okay. So you can say air pocket inside the bell. Okay. And one thing you need to notice that the pressure inside the bell should be going up as the bell is going down into the sea. Somebody can answer that? How many, or how can I say, how the pressure is increased down to the sea? How much pressure is going up by the depth of the water? Can somebody answer to this? Nobody? Usually, see, the pressure is same as the weight of the material surrounding us. So pressure at Earth, when we are in the air, the air pressure, we call this is atmospheric ATM something. That is 1 ATM. That is a weight of air onto the surface of our skin. And that is the total weight of the air above us into the sky. And then as we go down to the water weight above us is acting as a pressure to us. So as water is going deeper, the pressure is going up, but how much? Roughly, we can say that 10 meters of depth gives you one more atmospheric pressure, 1 atm. So depending on the depth of the diving bell, the diver should feel the pressure is going up. All right, and the bell in the orange color and the second image, that is looks like a submarine, submersible. So that is compressed device chamber, so that the human can stay there under normal pressure of air, depending on the device is controlling the pressure, right? But because outside of the chamber, the pressure is very high because of the water depth, the diver should have a time to adjust their pressure differences. So anyway, the pressure inside the diving bell can be controlled in modern diving bell system. And right-hand side, this is a clothes or suit, diving suit. And it is very similar to space craft in outside of Earth. But the pressure direction is different. Under the sea, the pressure outside is high, but above the air and outside the space, Earth, the pressure inside is high. There is no pressure outside. But anyway, that suit, the diving suit, protecting human from the pressure. Okay. And ocean vehicle is different types and classified into first one is surface vessel, very normal to manned surface ship, and there can be an unmanned surface ship in these days, very similar to unmanned car. And then underwater vehicles, a typical one is submarine and submersibles. But also there comes a new type of unmanned underwater vehicles. We call in short names UUV and others. And others looks like a airplane, right? But that is very special airplane, and also it is called as a kind of ship rather than airplane, because the device object is flying very near the water surface. We call this is what is like ground effect ship. WIG, weak, or what is the what W means? Wing in ground effect ship. Okay, wing in ground effect ship. So it has a wing, same as an airplane, but that gives you a very high pressure difference between wing, because usually the airplane flies up due to the surface pressure difference of lower surface and upper surface. But here in WIG, WIG, because of the water surface, the pressure difference is much higher than normal airplane. That is the key difference between WIG and airplane, normal airplane. We'll see in the later stage. And submarine and submersibles. Submarine is for the Navy. You see it in the left-hand side, but submersible is for the scientific research. So it is usually smaller than submarines, but the property is that it is used for much deeper depths of the water for the scientific research and laboratory, rather than submarine. Submarine is for the battle, so that they don't need to going down to very deep water, such as 1,000 meters down. They usually stay around 100 meter or 200 up to 200 meter depths. Navy submarines, that is enough for them. But submersibles usually goes down to several thousand of meters. So here at the right-hand bottom side, you see that there is a letter on top of the submersibles. It is a Japanese letters saying Shinkai 6,000 something. And that means the water depth the submersible can reach is 6,000 meters. It's much deeper operational limit. So, do you have any question? All right, chatting. Okay, right. You answered in here. 1 ATM per 10 meter, approximately. Right. Thank you. You already did this. I missed this one. All right. Thank you. Right. And then robotic vehicles. That is unmanned operational vehicles. And there are also two different kinds. One is ROV, the other one is AUV. ROV has a cable, remotely operated vehicles. So that cable goes to the mothership on the surface of the ship. So the cable, you see at the bottom pictures, you see that there is a cable. Very looks like an umbilical to the baby, attached to the mother body. Very similar one. And that cable gives you the ROV power, electric powers and also the communication cables. That is the main function of that cable. Also, control signals are going down and up. The communication power is the main thing the cable gives. And AUV is autonomous underwater vehicle, and they do not have such a umbilicals or cable. Then they need to have enough battery power to use the energy for a long time. So that is the main limitation of this AUV, because they cannot go far away. Also, another problem is the communication to the mothership or human body, so that the operational range is limitation. Also, the left-hand side also has a limitation because of the length of the cable. All right. We have any question? Chatting. Okay. Good. And this is an unmanned ship is now emerging. A new trend in surface vessel operation. The human body is just testing small cargo ships with unmanned cargo ships in these days. So it is very new trend, not popular yet. Right? So there is, you see that there is no hotel facility on top of the ship because there is no human. And this is also another concept graphics picture of unmanned ship or container ships. The image comes from Rolls-Royce. You see that the picture, the name of the company. It's just a concept computer graphics. Probably they started to build a small size of this kind of ship. You may count the number of boxes on top of the ship, probably several hundred, 200, or 200 or 300 TU, looks like. So it's not a big container ship. Nowadays, big container ships carries more than 100,000 TU. And this one is underwater drone. Same idea as a drone on the air. So very small, battery powered. And the shape is very interesting. And also this looks like this another kind of underwater drone. The shape is similar to the air drone. And there is one hand hook so that they can carry some cargo, small cargos, using this hand. Right. So that's it for the previous slide set.